Hey everyone, this is my first radio video and hopefully you like it. So what I've got here is an old radio that I've been working on restoring. I've already recapped it and there's a little bit of a hum still remaining. I think I've located the source. I just need a new rectifier tube. But what I did is I've got a whole bunch of other radios I want to restore, and I picked up an oscilloscope this past week. And I was just kind of playing around with it, and I've stuck it on the local oscillator tube and kind of saw the super heterodyne process in action, and thought I'd share it since it kind of gave a little bit more concrete example of how these things work than what I'm used to seeing. So to get started, so basically what happens, as a little background for the super heterodyne process, you have your radio frequency, you add a local oscillator frequency to it, and then, well, you mix those two together in the radio in a mixer, and you get both the sum and the difference of those frequencies. And usually what will happen is one of those frequencies will get filtered out, and the other will be passed along through everything else to be amplified and turned into an audio signal. So what I've got here is I've got the radio, and I'll just go ahead, the knobs are way off on tuning. But what I can do here is tune in the station as best I can. Alright. So that's as tuned in as it's going to get. And then I come over here to my oscilloscope. And like I said, this is tuned to the local oscillator. And each division here is 0.1 microseconds. So we've got 1, 2, 3, 4, 5, 6, 7 microseconds per cycle. Alright. So I take that, my local oscillator is 1 cycle per 0.7 microseconds, which is 1.428 cycles per microsecond, which turns into 1.428 kilohertz or kilocycles. Okay, so coming back up here to this formula here where we have our radio frequency minus our local oscillator equals our IF, we can turn that all around and say that the local oscillator frequency minus the intermediate frequency equals our radio frequency. And so what I've done is I've taken that 1.428 kilohertz and I've subtracted out the local oscillator frequency, which I know by looking at the service documentation for this radio. So it's 455 kilohertz. And then I get a result of 973 kilohertz. And the cool part about this radio, or this process, is it works, right? The station ID is 970 AM here in Portland. The dial you can see it's upside down right now, but you've got it set on 9 here, and I've got my band spread at about 58 or 56. So it's a little bit off. It's actually tuned to 956 on the radio, but that's the whole point of me restoring it, is getting it to work again. So yeah, that is the super heterodyne process kind of made concrete. I hope you enjoyed it, and I'll see you guys around.